In this video, we're going to talk about how to evaluate composite functions given a formula, and talk about the domain composite function, and also decomposing them. So how to evaluate a composite function given a formula. Evaluate the inside function using the input value or variable provided, and then use the resulting output as the input to the outside function. Okay, so, and I'm calling, in this case, h is the outside function, f is the inside function. And so we have f of t equals t squared minus t, and h of x equals 3x plus 2. So let's look at f of 2. That's 2 squared minus 2, which is 4 minus 2, which is 2. So h of 2 is going to be 3 times 2 plus 2. So that's what? 6 plus 2, which is 8. And then if we look at f of negative 2, it's negative 2 squared minus negative 2. So 4 plus 2, which is 6. H of 6, which is the output for f, is going to be 3 times 6 plus 2, which is 18 plus 2, which is 20. Now the domain of a composite function, f of g of x, is a set of values whose inputs x are in the domain of g, and for which outputs g of x are in the domain of f. So we're looking at what's allowed in case you have a function that has a radical with a variable under the radical that or a fraction. How to determine the domain of a composite function? F of g of x, where g is the inside function. So find the domain of g, find the domain of f. For those inputs x that are in the domain of g, for which g of x is in the domain of f, that's going to be the domain. So exclude the inputs x from the domain of g for which g of x is not in the domain of f. Resulting set is the domain f of g of x. So find the domain of f of g of x, where f of x is 5 over x minus 1 and g of x is 4 over 3x minus 2. So we're first going to look at, for g of x, we have to exclude something that makes the denominator 0. So where is 3x minus 2 going to be equal to 0? That's where 3x equals 2, or x equals 2/3. Okay, so when x is 2/3, g of x is 0, so that's excluded. Now the second part, we're going to say, where is f of x going to be undefined? So we take a look at f of x and say, okay, well, where x minus 1 equals 0 is where x equals 1. So we want to know, where is g of x going to be 1? Where is 4 over 3x minus 2 equal to 1? So that's going to be 4 equals 1 times 3x minus 2. 4 equals 3x minus 2. We add 2 to both sides. 6 is 3x. So x equals 2. So our domain, we have to exclude a 2/3, we have to exclude the 2. So it's going to be negative infinity to 2/3 union 2/3 to 2 union 2 to infinity. Okay, let's try another one. Find the domain of f of g of x, where f is 1 over x minus 2 and g of x is the square root of x plus 4. So first of all, that square root of x plus 4 can't be negative. So x plus 4, we're looking for it to be greater than or equal to 0. So x is greater than or equal to negative 4. So that's where we're starting. And now we're going to look at what makes f of x undefined, or not, or what we have to exclude there. So if we look at that denominator, it's x minus 2 equals 0. So x equals 2 can't be allowed. So that x plus 4, when is that equal to 2? That's when x equals, if I subtract 4 from both sides, negative 2. So we have to exclude negative 2. So it's going to be bracket now, negative 4 to negative 2, parenthesis there, union negative 2 to infinity. And there's our domain. Now the last part of this section, which I think is the most enjoyable part, is decomposing a composite function. Is breaking the composite function into two simpler functions. So we have a couple of examples here. So write f of x equals the square root of 2x plus 5 as a composition of two functions. Some people get lazy and just say g of x is going to be x, and then h of x is the square root of 2x plus 5. And that's trivial. That's kind of a waste of time. It's right in front of us. So you have actually a lot of choices. But if we're considering this to be f of x equals h of g of x, g of x is the inside function. So the way I approach it, I just say, okay, how about everything under the radical? G of x is equal to 2x plus 5. And then the outside function is just taking the square root of that, so square root of x. Now you could have said g of x is 2x, just the 2x. And then h of x is the square root of x plus 5, because that 2x goes in place of the x. So, and there's actually an infinite number of combinations. These are the two that just jump out as most obvious. And let's try this last one here. Write f of x equals 4 over 3 minus the square root of 4 plus x squared. Now, again, you have a couple of choices. I'm going to go off the premise that f of x equals h of g of x. So one option is to say g of x equals 4 plus x squared, which would mean that h of x would have to be 4 over 3 minus the square root of x. Another way to do it is to say g of x is the square root of 4 plus x squared, and h of x equals 4 over 3 minus x. And there's a third one. You could say even g of x is 3 minus the square root of 4 plus x squared, and h of x is 4 over x. But these are just some examples. So I hope that makes some sense. And now go forth and do the homework.